Hi, everybody. I'm Ashok Bhatt, Senior Product Manager at ARM, looking after open source tool chains. And today I'm going to talk about GNU and LLVM tool chain, what's new and what's next. And when I say what's new, this is what has happened in the last 6 months to 1 year in the various major releases. And when I say what's next, it's what's coming in the next 6 to 12 months. And this kind of includes not just what ARM has been doing, but kind of ecosystem view as well. So as we go along, you'll see areas where Linaro has been contributing and other ARM ecosystem partners have been contributing. I'll take a look at the Slack channel at the end. If you have any questions, we can answer that. All right, let's move forward. So what's the agenda? We're going to talk about the bare metal tool chain first. There I have an update on a GNU embedded tool chain. So this is one of the popular toolchain products that we ship, and it's kind of used as many IDEs and very popular in the embedded microcontroller market. Then I have an update or plan for LLVM bare metal toolchain. We'll talk about generally the architecture feature support in the last version of GNU and the next plan, what is planned for next version of GNU, and same thing with the LVM. Specifically, I'll talk about a bit about SV and SV2 support because this is one of the big items, and it's been a lot of heavy lift over many versions now. Fortran is a new entry, so I'll talk a little bit about the what's going on in LLVM flang and how the ARM and ecosystem and they're kind of working on this. Final set of slides. Maxim, who heads the toolchain working group in Linaro, has given me a few slides that covers what Linaro is planning to do in the next planning cycle, I think roughly 6 months. All right, let's get started. So first, the embedded tool chain. This is a free tool chain that we provide. We've been providing for quite some time now, and it covers bare metal use case, mainly on 32-bit ARM cores. So initially it was just Cortex R and M, so microcontroller class devices, but as of last release, which was done in April, I think, we started supporting even 32-bit Cortex A cores because microcontrollers and that segment, there's a lot of A53s and that class of devices now. So we started adding that, and now it's basically 32-bit bare metal embedded toolchain. It's released twice a year. One major release typically happens in the last quarter of the year. So in this year, it'll be September to December. And then there's an update release that happens just I think mostly in April to June timeframe. It's timed so that we can do a major release based on the .2 version of the GCC and the update release based on the .3 version of the GCC. So recently we did, first thing I want to call out is the update release. And that happened, I think if I remember correctly, May of this year. The two big features that came in was it was Mac notarized, the Mac version of it. It's a first notarization that we have done for the toolchain, which means it can be used on any Mac hardware today. And then we also added the 32-bit Cortex A support, as I told earlier. One of the unique things we did this year, I mean, this is mostly one-off, we're not going to do every year, is we made the preview release available in June. And this is a preview release for GCC 10, and mainly for end users to try the new features in Cortex M, the MBE support, and the custom data path extension, the CDE that was announced late last year. So that's the preview release that's there. And both of this kind of available in our download site. If you're not familiar with it, let me quickly show the download site. So yeah, this is our download site, and you can find all the releases here. So from the Q2 and preview, and the release is going all the way back many years now. All right, what's coming next? We are going to do a proper release of the 10 series, which is called 10-2020 Q4 Major. It'll be GCC 10.2 based release, and it'll have the MBE and CD support. So we expect this to be shipped as part of IDEs next year. All right, that's the GNU ARM embedded toolchain story. There's been a growing request, desire for having a similar toolchain based on LLVM. And we have started the work on it. It's going to be very, very similar to GCC bare metal toolchain. It's basically the same segment, assembler, compiler, linker, libraries, all that. And it's free to use. It's built on top of LLVM open source components, LLVM linker, LLVM debugger, and a whole bunch of those features, and then new lib for the C libraries. The alpha is available for kind of early access lead partners. If you're interested, please get in touch. We're working towards a public beta release in mid of 2021. So before this version of Linaro Connect next year, it should be available for anyone to try. This is going to be hosted on GitHub. I think at that point, we'll just open it up as a project as well. So this is in addition to GCC toolchain. There's no plan to stop GCC toolchain anytime soon. So for foreseeable future, maybe 2-3 years from now, you'll have both toolchains being released at almost the same time. Moving further, let's talk about the architecture support. GCC 10 was one of the big versions of GCC when it comes to architecture support. We had SVE intrinsic support added for the first time. Outline atomics, this was done by Linaro, which basically detects at runtime whether the hardware has LSE atomics 8.1, ARMv 8.1 LSE atomics or not. This has been since then backported to GCC 8 and 9 and has been found quite successful and useful in Neoverse N1 deployment so far. Then we added 8.6 support. So this is basically bfloat 16 and matrix multiplier extension, both intrinsics for A profile. For M profile, as you saw in the previous slide, we added custom data path extension and MVE intrinsics. So what are we doing next? We're doing MTE heap tagging and stack tagging is going to be further out. Then we are doing SV auto-vectorization improvements, MV auto-vectorization. So GCC 10 did not support MV auto-vectorization. GCC 11 will support some MV auto-vectorization and GCC 12 will have further support. And then the ARM AR64, ARMv8R support. So the 64-bit R profile support will add in GCC 11. There is a website, there is a web page that I maintain on developer.arm.com. And it contains not only the details of GCC, but also contains other components. I'll quickly show that it's been found useful by quite a lot of users. So I'll just go through quickly what this is. So it has M profile detail, A profile detail. For all the major features, you can see as to which version of binutils and GCC and glibc and GDB added support, right? So across all the different GNU tool chains. It not only has a status, which is captured here, but you can also see some stars. These mean that it's not released yet and it's planned for future. And wherever we have visibility, we make it public. So for example, MTE stack tagging, we are targeting in GCC 12. So we have almost roadmap visibility for up to 2 years from now. This is a page I would recommend to check if you want to know which version of GCC you need to use a particular architecture feature. Okay. So looking at performance side of GCC 10, GCC 10 was one of the spectacular versions as far as the performance improvement was concerned, especially when it comes to spec. There's a blog in which we have described what all has gone in. This is almost 10% uplift for GCC 10 versus GCC 9 spec-int. And this is on Neoverse N1. We've seen similar kind of uplift on other platforms. And roughly half the contribution came from ARM and the other half came from partners, specifically Ampere in this case. And it's been one of the big movement. I think in absolute terms, 10% is what we might have got over last few years. All right, moving further, let's look at LLVM architecture support. So LLVM architecture support, we've got so LLVM 11, even though it's not been officially released, it's about to be released. There is release candidates that are available, so I'm just covering that. And you can see it's a similar kind of features that were added in GCC 10 are part of LLVM 11. For LLVM 12, we are trying to get the outline atomics support ported to LLVM as well, not just GCC, and the SV2 initial auto-vectorization. So I'll give an example of what this initial auto-vectorization means in a subsequent slide, but that's what is being looked at. Again, going back to the roadmap page that it's available on developer, it's a similar kind of page as GNU. So if I go to LLVM, so you not only get an idea of which version has what, but you also have a coverage of LLD and LLDB, which versions are happening. And the LLDB work is mostly being done by Linaro exclusively. And we are targeting a lot of LLDB enablement for key architecture features in LLVM 12. All right, coming back to the architecture support. So let's quickly look at the SVE, SV2 intrinsic support in GNU and LLVM. On the upstream side, we have GCC 8 supporting SV auto-vectorization. So that's happened in GCC 8. GCC 9 made further improvements. 10 is fully ready for any SV kind of work. It has full intrinsic support on auto-vectorization. We continue to make improvements close to, whatever we found in Zeus relative to Zeus and Perseus, we'll try and get that in GCC 11. As you may have seen an announcement by ARM recently, both Zeus and Perseus have SVE. So those will be the first ARM cores to have SVE support. And we're trying to ensure that GCC 11 generates good code for that. On the LLVM side, it's been a difficult, long journey, I should say, but we made sizable progress. So with LLVM 11, you should have full intrinsic support, which means it's kind of on par with GCC 10 when it comes to intrinsics, assembly, and disassembly. For LLVM 12, we want to aim for the initial support of auto-vectorization. And what I mean by that is we use TSVC, which is a kind of vectorization benchmark. It has a collection of different kind of loops. And the vectorization compilers measure themselves against how many loops you can vectorize. And in LLVM 12, our aim is we at least want to do one or more loops in TSVC. So our downstream compiler can do a lot. We just want to ensure that the upstream starts with one and then goes more and more. The goal is by LLVM 13, we should not have any gap between what we have downstream and what we have upstream. So all the things that we have downstream, we want to just make sure it's part of LLVM 13. So that's the SVE story. Moving further, LLVM Fortran. So this is another area, not relevant to embedded segment, but highly relevant for HPC, supercomputing kind of segment. There's a project called Flang that was originally started by NVIDIA team, and they open sourced it in 2017. It's the GitHub link shows where to go to get the sources of it. It has 2003 and 2008 support, but it was written in a different era, so it has different style, which is not compatible with LLVM. Hence, PGI/NVIDIA decided that they will write a new Fortran frontend from scratch with all the LLVM features, LLVM rules being followed. And that was accepted in LLVM project, I think, in 2019 Euro LLVM. And it was made as part of LLVM project early this year, April this year, I think. And the main contributors for that has been NVIDIA, ARM, and AMD so far. So ARM and AMD have been working on the OpenMP part of it. NVIDIA have been working on the Fortran 77 support. So there's a talk by NVIDIA at the upcoming LLVM Developer Summit, giving an update on where they are with the F18 project. So ARM ships commercial compiler, AMD ships their AOCC compiler. Both of them use Classic Flang as a front end. So we continue to maintain that and add fixes, improve debugging, because that's going to be the front end of a compiler for foreseeable future while the new Flang comes on board. So the maintainers, it's a kind of a open source project where the maintainers are NVIDIA, ARM, AMD, and Huawei at this point. And if you're interested, please take a look at the wiki mailing list of the Slack channel. So it's a public open for all meeting that happens almost every week, covering different areas of the Classic Flang and the Flang project. Right. That's the Fortran story. Now I'll quickly move to the Linaro toolchain working group proposed plan. I don't want to go through in extensive detail, but the slides will be available later, and all the links that are there are publicly available, so Jira links. So in terms of GNU toolchain, they continue to work on code speed improvements, both AR64 and AR32. Especially on the debugger, Linaro has taken a lead with working on GDB, both on the AR64 and AR32 side. On the LLVM toolchain, Linaro, for the first time, has started working on Fortran. So they'll start working on Fortran front end. And also for security sensitive applications, stack clash support, which is there in GCC toolchain. Linaro will start working on the stack clash toolchain. The goal is to complete the stack clash support by LLVM 12, which is the next LLVM. So they're going to work on that. Like I showed in the earlier LLVM toolchain roadmap, debugger is almost exclusively done by Linaro LLDB. And debugger architecture features all the way from 8.2 to 8.6 is kind of being worked on. Code size optimizations continue to happen. It's aimed at 32-bit bare metal kind of use case. The last big item that Linaro is going to be working on the next 6 months is, actually they've already started work on this, is the Windows on ARM native toolchain. So what this means is if you have a Windows on ARM laptop or Surface device, you will have an LLVM native toolchain by LLVM 12. And that's what we are planning. We're making good progress. Linaro has already been established. They've created some build bots. They found issues. We and them are working right now to try and fix those issues. So we're confident that we will hit the LLVM 12 goal of having a native official toolchain. The details of this is available here. I mean, all these links are now open. They're all Jira links. They're all open. You can take a look at them, comment at them, or you can basically engage with the development team using those tickets. Similarly for LLVM, all the tickets are kind of publicly visible. So that's mostly what I had as an update today. I'll share the links that I was talking about. So this is one of the most useful links I've seen partners benefit from, especially if you don't know which version of LLVM or GNU you need, depending on the architecture support. So, okay, any questions? Let's look at the Slack channel and see if there are any questions. All right. No questions. If you want to get in touch, you can use the Slack channel. I'll check later as well. Otherwise, thank you for your time.